So Nathalie, the floor is yours. Thank you again for accepting to present today.
Yeah, no problem. Does it work? Can you see the
perfectly?
Okay, I guess Samuel, you will start.
Yeah, we have a presentation. I'm going to do the introduction, but most of the talk will be done by Nathalie. So so I think in theory about democracy, a lot of legitimacy is coming from debate and decision making. Maybe Nathalie, can you go to the next slide? The decision is like the legitimacy of the decision is coming from the debate and the processes of its production. And this processes is often linked to deliberation. And it could happen at different levels with different crowds. We can have maybe 300 people, 100 people, like in the French Citizen Climate Convention, it was around 100. Or it could be a neighbor council where we can have sometimes less people, like 30, or sometimes it's 100 or so. But it could be different scale, and most of the time it's happening in real time. Maybe you can go to the next slide. There is I think, a multi-millennial tradition to use a physical object to represent our opinion in the physical space. So here you can see two pictures. On one side, there is a Greek wine cup from the 5th century. It was made to represent something that happened during the Trojan War, in which Greek have to choose between two competing claims, one of Ajax and the one of Odysseus. And you can see small token on both sides of the pedestal that represents the vote of the audience. And on the other picture, you can see some post-it boards. It's a picture that have been taken during the French Citizen Climate Convention, in which participants organize their ID in different structure, but also they represent sometimes their position. We will call this, during this talk, this approach like a stance, making a stance. So since 2010, we have witnessed the rise of civic technology, civic tech platform, and the platforms that aim to transfer this activity of localized, co-located deliberation into distributed online interfaces. And from 2010 to the present day, I think we have seen a range of platforms that support debate and deliberation from a variety of stakeholders. And sometimes they are used by state to organize debate and other activity. And in this platform, we can identify the same thing that taking a stance, which is often represented by visual elements. Here you can see on a side where people are adding token on a scale. This type of stance approach reminds us of the type of, yes, you can go to the next slide. Other type of devices that ask people to input information physically into visual structure or physical structure to formalize different dimension or attribute of data. For instance, on the left, you can see Mobile by Hans Hackers that was asking in 1917 visitors of the mobile to position themselves relative to the Vietnam War and the US politics. Or example of more complex structure like where people document their process in the Fab Lab. During this talk, Nathalie will present two papers we have been working on during the last few months. The first one is under revision, so please don't share this work with other people. It's a visual analysis of 25 different debate platforms, online debate platform. And the second one is a design space and definition of what we call input visualization. They have in common one thing, which is how to provide a structure for collective data input with different size of crowd. That's help people to structure, it's like to structure the participation, but also the data characterization through either digital or physical means. Yeah, that's all I wanted to say for that.
Okay. Yeah, so I will start with the first project, which is called Jumping to Conclusions, a comparative analysis of online debate platform layouts. And this project has been led by Tallullah Frappier, who's a PhD student at Telecom Paris and Sorbonne. So since this project is concerned with debate, I will just start with some terminology. So debate can be seen, the terms debate and deliberation are often used or perceived as synonyms, but their definitions vary subtly. So debate consists of a succession of more or less opposing arguments on the same subject, whereas deliberation is an exchange of arguments and an evaluation of reasons for preparing a choice. So debate is thus a key mechanism of deliberation. So for this project, we are specifically looking at online debate, since there has, as Samuel mentioned, has been an increase of online debate platforms in recent years that allow individuals to share their opinions online. And a debate platform is any digital service accessible on the internet that is designed to host debates between several people. And research has shown that the design of these platforms has a significant influence on the quality of the debates. So this is why we have been investigating the question, how is debate designed online, where we specifically looking at if we can identify different types of debate platforms and what are the design patterns displayed in these platforms, and also how is the practice of debate framed by these graphical user interfaces. So to address this, we have conducted an analysis of debate platforms through the graphic schematization of their interfaces to develop an understanding of their prescribed uses and functionalities. And this included investigating common interface blocks, hierarchies, and layout. So we collected debate platforms from several civic directories, and we screened and selected the ones that claimed to be about debate by themselves, and we also analyzed their self-descriptions. So in the end, we ended up with 25 debate platforms. So to deconstruct the hierarchy of the visual interfaces, we employed a common graphic design technique, which is creating a wireframe. So wireframes is typically an outline of the basic structure and organization of visual elements of a user interface. And we adopted a similar approach to identify the hierarchy of blocks in these web pages, just in reverse order. And we refer to this process as reverse wireframing. So for each of the platforms, we took a screenshot of the page presenting the debate functionality. Then we drew a detailed wireframe on top of each screenshot to graphically identify the main hierarchy of user interface blocks. And then we coded each of these blocks and assigned roles to each of these subsections in order to identify the functions of each block in the interface. So a block in this sense is a set of interface elements that can be brought together as a coherent visual and interactive unit within the layout. And then we abstracted the detailed wireframe into an abstract wireframe by simplifying the wireframe into blocks of colors. So we wanted to identify the hierarchy of information in the graphical layout and also help visualize the coding created in the previous step. Then we created a mosaic of the abstract wireframes to facilitate the comparative analysis and to identify differences and similarities between platforms. And finally, we analyzed this mosaic to identify themes for the layouts and the content hierarchy. So first, to give you a brief overview of the corpus, our corpus includes platforms from various countries, including France, the US, Canada, Estonia, UK, the Netherlands, Spain, Argentina, New Zealand, and Iceland. And some of them are non-profit, while the majority are held by companies. And while some platforms are directly accessible to the public to debate topics, a large number of these platforms offer a service to public or private clients to realize their projects with the help of the platform. And so based on the description of the platforms, we identified 4 types of platforms. Most of the platforms in our corpus are presented as tools for participation through debate. So they are initiated by an organization to give a voice to the individuals who make up or lead in processes of ideation or consultation. The second type is social network platforms, which are distinguished by their focus on relationships between users. And these platforms emphasize the need to form new interest groups or insist on the importance of creating a community of users, or sometimes they claim to offer a new type of social network. And the third group is what we call encyclopedia platforms. They have the aim to compile all the arguments on the subject. And in this way, they fulfill an encyclopedic role like Wikipedia, with a focus exclusively on documenting controversies or issues. And lastly, we also found debate as skills platforms, which present debate as an oratorical practice to be learned. And they have the common feature of designating winners in the debate, and they take an individualized approach, which resemble American debate clubs. So now I will give you an overview of the findings from our graphical user interface analysis. So as I said, the visual coding led us to the identification of interface blocks. And these are sets of interface elements that can be brought together as a coherent visual interactive unit within the layout. And that helped us understand the general layouts of the interface. So we identified three main blocks. The first one is the topic block, which displays the subject that is being debated. And it usually contains a headline, such as a question or a statement or an explanatory paragraph. The submit block is where people submit a contribution directly about the debate's topic. And it is the main block where users are enticed to participate in the debate, even though there can be other input elements within other blocks for people to use. And the two main input elements that we found for submissions were text and voting. And lastly, the submission blocks show the submissions of users, and they can therefore be a display of text or votes. And when displaying text is involved, the block often contains an identification system showing the author of the contribution next to the submission. And when displaying votes is involved, it takes often the form of an information visualization, such as a pie or a bar chart. So one prominent feature of the interfaces in our corpus is the consistent sorting of users, arguments, or votes into recurring categories, typically labeled as for or against, also occasionally incorporating a neutral standpoint or other scales, which we call a stance mechanism. So the stance mechanism can occur in all of the blocks. So for the topic block, this can be the topic that is organized into arguments for and against, which directly separates the topics into two opposing points of views. In the submit blocks, users often have to label themselves or the arguments they are submitting in relation to the subject for the debate. So for example, by voting for or against or have with a neutral position. Or for text, an interface organization can be that the user is required to take a position in a column before writing their arguments. And for the submit block, correspondingly, each argument is then labeled as for or against, and sometimes displayed in assigned columns. So stance mechanisms are present in most of the platform, which you can see as stripes in this overview. So in the end, the interfaces can be entirely structured by these position declarations. So we also looked at the placement of blocks and their hierarchies. So the placement of blocks and functionalities in a web page is made according to their importance, with important elements being placed higher. So we found that the topic block is the first block in 25 of these interfaces. And the majority of the platforms follow the topic submit display hierarchy. which were 20 interfaces, and 4 of them actually showed a display block before the display block before the submit block. And then we had 2 outliers, with one actually starting with the display and one that didn't have a display block at all. And for these layouts, we for the display layouts, we also identified 3 ways that submissions are displayed. One is a discussion thread, which is akin to a traditional internet forum. Stance column, as I've already showed, divide the submission into columns based on the stance. And rounds are specific for the skill platforms, where each participant can only write one post per round, where they oppose each other. So so what does this mean? So definitions of what constitutes a debate can be varied, and we also collected platforms which have a variety of different purposes. Even most of them were participation platforms. And our analysis of the debate platform shows that there is a strong similarity of how these platforms organize their content, with some notable outliers. So our findings point towards homogeneity in how debates are designed online. So the presence of topic, submit, and display interface block is in accordance with common definitions of debate, where people give their opinion, and which is the submit block, and exchange with each other points of views, which is the display block, on a specific topic, which is the topic. And as we've seen, most platforms follow the topic, submit, display hierarchy, and this hierarchy emphasizes creating a submission on the topic before reading or engaging with other people's submissions, which is hence the title of this paper, Jumping to Conclusions, as these interfaces seem to prioritize collection of individual contributions. To finish up with this part, how can we break the mold of online debate? So our identification of common blocks, hierarchies, and layouts provide a classification for rethinking the organization of online debate platforms. So I will briefly touch upon 3 points. So one consideration can be the diversifying of stances. Most platforms structure debate around opposing positions, but we also have looked at some outliers which offer a third option, or even a spectrum of possible stances. Also, stances can relate to different things. They can relate to people, or they can also relate to arguments, or a mix of both, which emphasize either more individualized opinions, or maybe even more, on the other side, a more collective construction of debates. And with our findings on the hierarchies of debate platforms, can also point towards potential new structures of online debates by mixing up these blocks, and also maybe more seamlessly blurring the boundaries between them. And it is also important to align the hierarchy with the intended type and purpose of the platform. So lastly, however, our study also raises deeper questions about the design of debate online, which is mainly, can debate be more than engagement, which points towards questions like which stakeholders are considered and prioritized during the design process of these platforms, and what are the main motivations and inspirations behind the actual designs, and what are the design processes of these platforms. This is the first part of my talk. So now I will switch topic a little bit, and then we will try to connect those two in the end. So the next project I'm going to present is on input visualization, as Simone previously mentioned. So what is input visualization? So the area of information visualization has traditionally been concerned with visualizing existing data. Yet there are a variety of visualizations that do not follow this approach and instead use visualizations for data input. And we call these visualizations input visualizations, Samuel has already shown a couple of them in the previous slides, which are visual representations that are designed to collect or modify new data rather than encode pre-existing data sets. So to help unpack this idea, I will start by highlighting 4 case studies. So this is the first example. This is an example from the New York Times, which is called The Death of a Terrorist, which was published in 2011, just after the killing of Osama bin Laden. And this interactive visualizations lets viewers indicate their feelings about that event by marking a point in a 2-dimensional scatter plot with significant, insignificant, and positive, negative axes, and then adding a comment. And over a few days, these inputs created a visualization of readers' overall sentiments with over 13,000 data points. Another example that most of you will know is Doodle, which is an online scheduling tool designed for facilitating meeting coordination, and it allows multiple participants to collect and visualize schedule availability based on a preference matrix and a timeline. And a physicalization example that we have also already previously shown is Cairn, which represents the activity in a makerspace, and Cairn uses a much more complex visual encoding schema with composable physical tokens that let makers record both quantitative and qualitative information about their projects. And the last example I wanted to point out is Polemic Tweet, which is an example that Samuel has worked on, which used visualizations to engage users in an evolving discussion around conference presentations. And it included a Twitter client that invited viewers to tweet using a specific grammar, which was then visualized with these texts alongside the discussion. So input visualizations invert traditional information visualization models and design guidelines. And by emphasizing data input and modification rather than traditional visualization goals like perception, exploration, or communication, they force a rethinking of the relationship between data and visuals. And recognizing the potential for visualizations as data input also reveals unexamined use cases for visualization, as well as interaction techniques and tools. So with this project, we aim to conceptualize and describe the phenomenon of input visualization to make it more actionable for the InfoVis community. And by doing that, we want to investigate characteristics of existing input visualizations, and also with that open up new research opportunities around input visualizations. So we did this by creating a design space of existing input visualizations. So we collected 50 curated examples of existing input visualizations from research, art, commercial products, journalism, and personal projects. And we included both visualizations and physicalizations. And we coded these examples based on 16 dimensions. And then based on that, we extracted purposes of input visualizations, as well as a set of design considerations. So this is an overview of all the examples in the design space that we have created. So we organized the 16 dimensions into 5 high-level categories, and I will briefly summarize our dimension encoding based on these categories to give you an overview of the space of input visualization. So we saw diversity of visual idioms of visualizations and physicalizations, including common idioms like bar charts, as these physical bar charts, or scatter plots, as with Death of a Terrorist, which I've already shown. But we also saw a mix of idioms. Doodle is an example, which is a mix of a timeline and a matrix, and also custom idioms like these drawn data portraits. So we found also a diverse type of input data, although subjective judgments and activity tracking were especially common. So this is Comparative, which is a deliberation platform to visualize stances of people, which was also in the corpus of our last study. And the number of data dimensions varied greatly from 1 up to 13 dimension, which enabled different type data input of different types, including categorical, ordinal, text, and quantitative data. And the artifacts in our collection include visualizations on a variety of display types, like this communal plant watering tracker, and also physicalizations made out of diverse set of building materials as this conference data badge. And while some were highly customized artifacts intended for a single purpose, as this previously shown example, which was exhibited at the MoMA, a range of commercial products and toolkits also allow people to author their own input visualizations and physicalization, like the Let's Play with Data kit. So input visualization is not a phenomenon that is limited to a certain domain and may also come from areas that are underrepresented in information visualization research, like personal tracking, time management, and civic participation. And our examples supported various timelines of use, ranging from minutes to months or indefinite time frames, like, for example, a personal calendar. And they also facilitate diverse numbers of participants, from individual users to hundreds of thousands of people, like, for example, in a Twitter poll. And we identified examples that supported a variety of high and low level tasks, as well as synchronous, asynchronous, co-located, and distributed input. So we identified 6 different input modalities, which include manipulating tokens, interacting with controls, drawing marks, forming materials, interacting with the body, and authoring words. And while a lot of these examples use tokens, as they can correspond to a one-to-one mapping with a row in a data set, we still saw a diversity of also different input modalities. And although physicalizations typically relied on embodied interactions with data elements, visualizations incorporated a wider range of mediated and indirect input approaches. So by clustering the examples based on high-level task, number of participants, data visibility, data activity, and the type of data, we identified 7 purposes for input visualizations based on common characteristics, which I will briefly go over. So individual reflection focuses personal data collection by an individual to support self-knowledge. And these include tools for capturing subjective judgments, like, for example, these self-trackers. Public group reflection examples allow multiple people to collectively reflect on a topic, as Considerate or the MoMA poll. And public activity documentation examples document ongoing group activities like Cairn or the plant watering trackers. Data discussions operate synchronously and allow ongoing collective discussions mediated by the input visualization, like polemic tweet or simple dot voting techniques. Survey examples include aim to collect data from a group of people, but the existing data is hidden during the input and only shown afterwards, which is the case for a Twitter poll, for example. And planning examples bring an explicit focus on time and logistics to help people make sense of ongoing time use, develop plans, and forecast future events like Doodle or a calendar. And finally, organizing examples focus on sorting and categorizing, often allow viewers to change the data points, attributes, or even data dimension, like a sandscape, which enables forming of sand, or a tier list maker. So based on our design space, we identified a number of design considerations. I will just highlight the first 2 to not make it too long. So one main thing about input visualizations is that they are dynamic by default and need both an assembly model and an approach to deal with dynamic data, which means that they suffer from the same kinds of scaling pressures faced by other visualizations of dynamic or real-time data, as the exact quantity, scope, and nature of the data that will be collected is often unknown. And we have seen different strategies of how to deal with that, which includes aggregation and binning, as in Death of a Terrorist, or aggregation and scaling, as in the Twitter poll. A subtractive approach, as in the Happy Show, where people remove tokens which also reduces visual clutter, or fading marks, as in the plant watering tracker. However, scaling pressures are biggest for physicalizations that require probably routine maintenance and a cleanup mechanism. So another design consideration is how the design choices influence the data that people will input. So for example, whether or not existing data is visible during input can have an impact on subsequent data collection. So survey-style designs where prior data is only revealed after an input is completed reduce the possibility that existing data will influence the new values. On the other hand, public group reflection and data discussion designs are often explicitly choose to surface prior data upfront to provide context and create a sense of social engagement, or to support reasoning based on prior responses. However, this means that each data input reflects a different state of the visualization, and the values are not comparable in the same way. And instead, these visualizations tend to serve as collective social artifacts which evolve over time. So to close up, so input visualizations is not a new phenomenon, but a recognition of a set of existing patterns, and considering these examples as visualization raises deeper questions about the nature of the data and the ways in which the InfoVis community has traditionally set its boundaries. Because most of these input visualizations don't neatly align with descriptions of visualization, which usually explain visualization approaches as visually encoding data to make it easier to understand. And input visualizations as mechanism for collecting and displaying new input information also raises more deeper epistemological discussions about the nature of data itself. For example, Drucker has already criticized the term data and advocates instead for the notion that all data is in fact capta, which is actively taken from the world. And the notion of capta and the considerations of the constructivist nature of data collection and visualization become even more important in the context of input visualizations, as they more explicitly surface the mechanisms of data collection. And lastly, thinking of input visualizations as input spaces also opens up possibilities not only for data collection, but also for cleaning, synthesis, and other sense-making tasks. And since they have the potential for new sense-making and also participation tools. And yeah, this is leading me to kind of summing up to the project that we are currently working on, for which these two projects build the base, which kind of combines debate, input visualization, and participatory design. So, Samuel, you wanted to close up? You're muted.
Sorry, the WebEx app didn't work. So I think in the first project, we saw the limitation of the design of an online debate platform and the space to redesign some aspect of them. We also saw the possibility to imagine the structure of the stance mechanism. I think in the sub-GOM project, we saw that we can not only consider information visualization as a data output system, but also as an input system. And I think we saw the diversity of input visualizations that exist and the opportunities they open if we consider like visualization also as an input system. To me, there is these things in like the first project we saw the similarity of how people debate online, and on the second project we saw a diversity of how people can input data in different visual structure. And I think it's lead us to like this question of, okay, maybe there is some hypothesis that could be made in terms of how can we increase deliberation procedure by using the knowledge that we have with the diversity of input visualization or visualization or way to structure the input of the people. I'm sorry, my computer is slow. So one of the questions that we have is, okay, how can we design visualization and physicalization to better support input during deliberation procedure? I think there is multiple opportunities that could be provided by this different approach. So we can have new we can go to the next slide. New modalities of civic participation, new conceptual model, and new tools and new application with trying to rethink the way we are asking people to interact with visual and physical objects when they are inputting. So right now with Nathalie and I are organizing several citizen consultation where we are empirically experimenting this idea, hypothesis, and question. We cannot really talk about the finding because it's like really what we are doing right now. So it's really an experimentation. We expect to have some more information later. Yeah, thank you for your time. I think that's all.